For this example, given that a complex number z and a complex number w, where I will be equal to square root of -1, so express for the first one, 1 over z plus 1 over w in the form of a plus bi, means we want in standard form, real part followed by imaginary part. So for here, we're going to substitute z, which is -3 plus 2i. Meanwhile, we can see when we have a division, when we have over a complex number, the way we simplify is multiply with its conjugate. So straight away, we simplify this operation. So plus 1 over w, 1 plus 5i. So same concept here, we need to multiply with it conjugate so that we can rationalize its denominator. Then we're going to simplify. So complex number times with its conjugate, always remember we can directly calculate a squared plus b squared. So here at denominator we can apply complex number times with conjugate. A is -3. When it's squared, it gives us 9. Then plus b is 2. When it's squared, it gives us 4. So for numerator, we're going to multiply as usual, which is -3 minus 2i plus, one more time, complex number times with conjugate, a, which is 1. When it's squared, also 1. Plus b is 5. So when it's squared, it gives us 25. Numerator multiply with usual as usual. So here we can notice that we have a real part -3 over 13, imaginary part -2 over 13i, plus here 1 over 26 real part minus imaginary part 5 over 26i. Then we're going to operate real part plus with real part, imaginary part plus with imaginary part. So when -3 over 13 plus with 1 over 26, it gives us -5 over 26. So imaginary part, -2 over 13 minus 5 over 26, -9 over 26i. So here we have the final answer and the form of standard form, which is real followed by imaginary part. Then we go back for question B, asks us express. So notice here we have a bar, means the conjugate of w. So as we know, w conjugate is equal to 1 plus 5i. So the conjugate of it, there will be 1 minus 5i. So we want the conjugate of w to be expressed in polar form. So in polar form, what we need is, the first one, the modulus of conjugate of w. Modulus equals to square root a squared plus b squared. So this is our value of r, which is square root 26. Then we need our argument. So before we do argument, we must know this complex number fall in which quadrant. So when we have real part, which is 1, imaginary part, which is -5, so this complex number fall in quadrant 4. In quadrant 4, the argument for this complex number, it will be negative. Shift tangent b over a. So value of b here without negative, which is 5 over 1, value of a. So this argument gives us -1.37. Bear in mind, your calculator must be in radian mode. So after we have modulus and argument, then we can express this complex number in polar form. So starting with modulus of the complex number in the bracket, cos argument negative 1.37 plus I sine theta. So theta is negative 1.37. So argument actually is our theta. So I want to remind here, when you're doing shift tangent for B over A, so here remember not taking negative, no negative, because we are doing this triangle B, which is a length of triangle 5, A, which is a length of triangle 1. So it's not the coordinate of negative, it's the length of the triangle. So this is the basic angle that we find. So in data, totally will give you negative alpha, so negative 1.37.